Good day everyone. For today's video, you will learn the relationship between pair of angles formed by parallel lines cut by a transversal for alternate angles. This video features an instructional material, particularly a figure labeled with both print and braille characters. The needed materials are braille paper, tracing wheel, and a marker. So let's get started. Before anything else, we will review some key terms. We have parallel lines. These are lines that do not intersect. Another, we have transversal lines. This is a line that passes through the two lines. In this figure, we have a pair of parallel lines AB and CD. Line AB is placed above line CD, which is cut by a transversal line EF with the following points of intersection. We have point H that lies on the line AB and point G that lies on the line CD. Now, we are given two angles. We have angles AHG and angle DGH. For the first horizontal line, we locate angle AHG by starting from the left at point A here. Then we go to the right until we reach the vertex, which is at line or point H. Then we go downwards until we reach the point G. So that is angle AHG. For the second horizontal line, we locate angle DGH by starting from the right at point D. Then we go to the left until we reach the point G. Then we go upwards until we reach the point H. Do you recognize these angles? These are the alternate interior angles. As a review, alternate interior angles are the angles formed when a transversal intersects two coplanar lines which lie on the inner side of the parallel lines but on the opposite sides of the transversal. Please remember that when two parallel lines are cut by a transversal, then alternate interior angles are congruent. This is also what we call as the alternate interior angles theorem. So, in our example, suppose the measure of angle AHG is equal to 42. So what is the measure of angle DGH? Using the alternate interior angles theorem, angle AHG is congruent to angle DGH. This means that the measure of angle DGH is also equal to 42. In our next example, we have angles BHG and angle CGH. So, starting from the first horizontal line, we can locate angle BHG by starting from the right. So here, we start at point B, then we go to the left until we reach the vertex which is at point H. Then we go downwards until we reach the point G. So this is angle BHG. For the second horizontal line, we locate angle CGH by starting from the left, which is at point C, then we go to the right until we reach the vertex, which is at point G. Then we go upwards until we reach the point H. So going back to our sample angles, if the measure of angle BHG is equal to 135, then what is the measure of angle CGH? Using the alternate interior angles theorem, angle BHG is congruent to angle CGH. This means that angle CGH is also equal to 135. Now we are given another pair of angles, namely angle AHF and angle EGD. For the first horizontal line, we locate angle AHF by starting from the left, which is at point A. Then we go to the right until we reach the vertex, which is at point H here. Then we go upwards and until we reach the point F. So this is angle AHF. For the second horizontal line, we locate angle EGD by starting from the bottom of the transversal line at point E. Then we go upwards until we reach the vertex, which is at point G. Then we go to the right until we reach the point D. So this is angle EGD. Do you recognize these angles? These are what we call as alternate exterior angles. As a review, alternate exterior angles are the pair of angles on the outer side of the two parallel lines but on the opposite side of the transversal. So please remember that when two parallel lines are cut by a transversal, then alternate exterior angles are congruent. This is also known as the alternate exterior angles theorem. So going back to our given angles, we have suppose the measure of angle AHF is equal to 150. So what is the measure of the angle EGD? Using the alternate exterior angles theorem, angle AHF is congruent to angle EGD. So this means that the measure of angle EGD is also equal to 150. For our last example, we are given two angles, namely angle BHF and angle CGE. These are also alternate exterior angles. For the first horizontal line, we locate angle BHF starting from the point B at the right. Then we go to the left until we reach the vertex, which is at point H. Then we go upwards until we reach the point F. For the second horizontal line, we locate angle CGE by starting from the left at point C here. Then we go to the right until we reach the vertex, which is at point G. Then we go downwards until we reach the point E. So this is angle CGE. If the measure of angle BHF is equal to 36, then what is the measure of angle CGE? Using the alternate exterior angles theorem, angle BHF is congruent to angle CGE. This means that angle CGE is also equal to 36. I hope that you learned something from this video. Thank you everyone. See you on the next video.